So I'm from a different kind of company. We are a large semiconductor company. And well, why did I have this embarrassing slide? It's different. I'm also different. I'm not a quantum physicist, but I learned electrical engineering. I learned semiconductor manufacturing, and now I'm learning quantum physics, and I think I'm well on my way. A quick one for you who might not know Infineon in detail. We are Europe's largest semiconductor company. Well, there is a dip at the moment in the market, but we made 16 billion in one fiscal year ago. Almost 60,000 employees, global footprint. And we are market leaders in automotive semiconductors, power semiconductors, and security ICs. And now we come to the topic of quantum. That's very unusual for a company like us. And first is one big good news, right? This session is also about how to scale, how to bring this into real life, into the data center. It will not be the QPU who prohibits that. It really doesn't matter if we produce another one. The challenge is to kind of produce the first one that can make then thousands and millions of qubits work. This is just as an example, and I want to then state a couple of things. This is for the ion trap activity. This is the lead site in Villach, Austria. And then you see from the numbers, this is high volume manufacturing. But what is wonderful about that why do you need high volume? We need high volume not now. For the ion traps that are in the current computers, you don't need that. Right? You can easily do hundreds of qubits with university clean rooms or lower volume fabs or RTO style, Fraunhofer style fabs. But when you want to do thousands on one single QPU or tens of thousands on one single QPU, you build up to direction of 10 metal layers. You have 2 to 3 optical layers. And you need this precision windows that each tool is running on, because there is, you see a million of chips, many millions of chips produced today. And the machines run in a very tight window and they're constantly calibrated. And that's wonderful that we can use that. That helps us in attacking these challenges that we have to bring new materials into the layers and stuff like that. But the fab in the 8-inch line really allows still for innovation. It's also possible in the 300 millimeters, which we might use later, but the 8-inch is more manual. And yeah, and this is a nice place, right? This is a zoom out of the picture. You see, this is where other people go on vacation. On the picture, unfortunately, you don't see the lakes. They are behind. There are plenty of lakes behind those trees there, and between the mountains and the trees. It's a really wonderful place, and I like to travel there from Munich. And well, Infineon is a long time in working with quantum, and that comes from our market leadership position in security ICs, right? We supply chips for payment, passports, like the US passport, for example, runs on an Infineon chip. And there we had to prepare for this future of powerful quantum computers that can hack certain security protocols, right? So post-quantum cryptography has been there for a while. And then let me move to the right side. We are also interested in the application, and we founded a German consortium called QTech, where half of the big industrial companies of Germany got together to work on the application of quantum computers. And also ourselves is for optimizing our manufacturing and supply chains. The chip shortage would have been much less when we would have powerful quantum computers at that time already. And then we provide, right? I mentioned ion traps. This is the area where we are already in a business phase. So we have plenty of partners and customers that you will see later, but we also work on the natural ones for a semiconductor company, which is the spin qubits and the superconducting qubits. And then some sensing activities going on as well with vacancies in silicon carbide. Here's some pictures of our hardware. If you come see me, you can touch one. I have a QPU with me in my pocket. Well, yeah, you see we also do two things that are really important for the future powerful ion QPUs. And that is we work on cryogenic control ICs. They need to be for these thousands of qubits, you need to integrate them in the vacuum chamber. And then we work on the integrated photonics and have great successes here. This is all fairly old pictures. The progress is really rapid, but the new pictures is always customer designs, and I cannot show them. And here's our team, right? Apart from me, it's really young. And also apart from me, it's 100% quantum. I'm the odd guy out here. And we run a couple of labs. We have one in Munich for cryoelectronics, and our ion labs are in Villach, and then we have a superconducting lab also in Munich. This is now just the ion team, as that's where I'm working on. We are by now more than 40. This is also old picture and located in Munich and Villach. And yeah, our partner network really grew. We had started from the very beginning with just working on a 100+ kind of chip. That's why in the beginning we're not having business. By now we are basically in working and exchanging thoughts and already having customer relations with basically every trapped ion company in the world. You see a couple of familiar names here on that one. And yeah, with that, yeah, don't need to repeat it. The age of quantum is coming, and we are there to help you make it.
Thank you.
Thank you.